this is Mike Pennella, and welcome to my lesson on color for the web. The first part of this lesson is all about color theory. This video contains hotspots that will let you link to the website activities and then return to the lecture. The best place to start is usually with what people know, or what most people know, and for most of us, that's the color model that we were taught back in elementary school, namely the red, yellow, blue model. So if you recall, you have your primary colors of red, yellow, and blue, and you can combine those primary colors to create your secondary colors. So for example, red plus yellow gives you orange, or yellow plus blue gives you green. And then from there, we can also create our tertiary colors by mixing a primary with a secondary color. So for example, we could take yellow and add it to the secondary of orange and create yellow-orange. And we could express this as a wheel of color, as shown here. And from those base colors, we can also create what is known as the tints, shades, and tones. Tints are adding white, and you see on the screen there from no white all the way to 100% white. And we can create our shades by adding black, and we can create our shades, we can create tones by adding gray, which is really just adding both black and white. So those are your basics. And from there, you can create these great-looking multicolor wheels, such as this one, which has, if I counted correctly, 240 colors. All right, so that all makes sense, but light is different. And you immediately get a sense of that when you see these three colored lights shining on the wall, and the main colors seem to be red, green, and blue. So that brings us to the red, green, blue model. So we start here with a close-up of what your device display looks like. It's made up of pixels of red, green, and blue light. And any color that you see created on that screen is a function of the intensity of three different values of R, G, and B, red, green, and blue. And those values will range from 0 to 255. So primary color, first of all, what does it mean in an RGB model? Well, it means it's the full intensity of one value for RGB and a 0 value for others, right? So red has a value of 255 for the red, and the G and the B are both zeros. And then you can see how this works out for green as well as blue. Now you may also see this expressed as percentages. So for example, rather than blue being 0, 0, 255, you may also see it as 0%, 0%, 100%, but same concept. So let's talk about black. Well, black is the absence of color, and so that has a 0 intensity for all the RGB values, whereas white is the full intensity for all three values. And you can see in this diagram that where the red, green, and blue light intercede or come together at full intensity, it creates white light. Now you may have heard this concept of an additive model versus a subtractive model, and I think it's a little confusing, but the way I always think about it is, how do you get to white? Right? So with light, if you add all the colors and turn them all the way up to full intensity, that's how you get white. So that makes it an additive model. In paint, if you add all your colors together, you get black. And so the only way you get to white is to subtract back to your kind of base point or canvas. So probably not the most technical explanation, but it's the way that I always keep it straight. All right, so now let's talk about secondary colors. What does a secondary color mean in this world of light? Well, it means the full intensity of two RGB values and the 0 value for the third. So in this case, yellow is made up of full intensity red, full intensity green, no blue. Similarly, you can see the derivation of magenta and cyan. And now as you move into your tertiary colors, again, you can think of this mathematically. It's the full intensity of one value, half intensity of the second value, and 0 intensity of the third. So for example, if I take spring green, it is full value of green, half value of blue, 0 value of red. So you end up with a color wheel that looks a little different in the RGB world. You can see that yellow ends up being right across from blue, whereas in the RYB model, yellow actually ends up being across from purple. So it looks a little different. The other thing to know is even though you still have this kind of concept of tints or shades, one doesn't actually add black or white light or even gray light to form those shades and tints. All of these colors are formed via the RGB intensities. All right, so this brings us to our first activity. And what I want you to do is create some colors using the RGB model. So what you're going to do is you're going to access the color schemer online through the link that's going to appear on the screen. Then I want you to try to play with some of the RGB values there and see how it creates colors. And see how it works out, what manipulations you have to make to try to make the colors lighter, darker, or grayer. Don't cheat and just go to the bottom there and hit lighten scheme, darken scheme. I want you to try to actually figure out how it is that you accomplish this, because it's kind of tricky and it's not the easiest thing, and there are models that we'll talk about shortly that are a little bit easier. All right, so when you're done with that, come back here and we will resume. Okay, so welcome back. Now, one of the things you might have saw when you're looking at the RGB or in your coding that you've done in your HTML work is that you don't often see, colors aren't always expressed in terms of these numerical values. You'll see these kind of mystical looking hex codes with these hashtags and mixtures of letters and numbers that don't seem to have any rhyme or reason on the surface. So just as an example here, I have picked the 13 colors that have been retired by the Crayola people, just as an example, and you can see both the RGB values and the hex code values. And you can stare at it for a minute, but usually it doesn't make too much sense intuitively. So, how does this hex thing work? And it's really not that complicated, and I think it's worth spending just a minute or two demystifying it. So how does it work? Well, hex is a base 16 system, which I know doesn't mean much of anything to most people, but think of it this way. So take whatever RGB value you have, right? Divide that by 16. Take the remainder, express it as a fraction in terms of sixteenths, and then you're going to translate that value into a hexadecimal using the decoder ring on the right. So let me take you through that. So imagine you have an RGB of 244, 45, 152, right? In hex, you're going to see why that can be called F4-2D98. And there should be a hashtag in front of that. All right, so for that first value, 244, we divide it by 16. It creates this 15 and 4/16. Use the coder on the right, and that codes to F4. You can do the same thing with the second value and get 2D, and do it with the third value and get 98. Put that all together, and what that would designate is, actually, it's a hot pink type color. All right? So that's kind of your hexadecimal notation. Now, again, what you've probably seen in HTML is that sometimes you don't see RGB values, and sometimes you don't even see hex. You see colors that are just called by their name. So there are such things called name colors. There are 140 colors that can be designated by name alone when you're working with HTML or CSS. There's 16 of them that are called standard colors. You can see those on the right. Somewhere along the way, with CSS, they added orange, and they have a link here that you can use to access the full 140 if you're interested in that. Now, are all these 140 colors web safe in today's world? Does that even matter anymore? Let's dig into that a second. So with this RGB system, since you can have a value of 0 to 255 for each one, if you multiply that out, that actually means more than 16 million possibilities in different types of colors that you can create. Now, to properly show all those 16 million plus colors, you need a 24-bit or greater display. All right? Trust me on the math here. If you take 2 to the 24th power, that gives you your 16 million plus number. So the big question is, well, how common are these displays that are 24-bit or more? Well, let's go back a few years, 2003. Back in 2003, only about 50% of the displays out there could properly render all those RGB values. So there was a real fear of this concept of dithering. And dithering is what happens when a color is lacking in the palette, so it has to substitute a pixel pattern instead. And you end up with something that looks a lot like the orange and green pattern that you see on the right. And because of this, this concept of web-safe colors had emerged. Well, let's talk a little bit about web-safe colors. Well, if you have an 8-bit display, which some people had, especially back in the late 90s, early 2000s, those displays can only render a limited number of colors. And the way to think about it is for each RGB value, you only have a choice of 6 different intensities. Okay, think of it this way. So you can have a value anywhere from 0, you can be 20, 40, 60, 80, 100. All right, those are your choices. So 6 choices for each color, 6 times 6 times 6, that gives you 216 choices. I'm also showing you what the intensity values are there, you know, the 0, 51, 102, and also what the hex notation is. One other thing, because if you peer closer at that chart, you'll see that they're not even using 6 characters for their hexadecimal, they're using 3, and that's because if you have a triplet situation like 3366FF, you can actually reduce that down to 36F. And because every time somebody shows me a color, I want to know what it is. That's a bluish color, just so you know. All right, well, now let's move forward a decade. So it's 2013, and more than 98% of the displays now are in a position to be able to render all those color combinations. I'm using statistics from W3, which may skew a little bit more higher-end displays because it's a more technical site. But it's a pretty good number, and it gives you a sense for where we're at. As such, the web-safe color concept in general has fallen out of use. Now, there is kind of a new sort of middle ground, kind of a new web-safe for the new millennium, if you will. And that is to design against a 16-bit palette. Now, 16-bit palette is also known as a medium color or thousands of color palette. And what it gives you is you have a possibility of 32 red values, and 64 green values, and 32 blue values. You put that all together, and that gives you 65,000 color combinations. Now, you might say, well, why do you get more on the green? And, well, as it turns out that the human visual system has a greater ability to perceive differences in green than it does red or blue. And so these systems take that in consideration, allow for a greater amount of values or possibilities in the green spectrum. So how would one use a 16-bit palette? Well, it's not too complicated, and it's more of a mathematical thing. So when you pick out your RGB values, anything that's red or blue, you look for values that are multiples of 8. So 0, 8, 16, and then 255 is the full value, recognizing that 255 is not a multiple of 8. On the green side, you get to take smaller steps, going from 0, 4, 8, 12, and so on. And so an example of a 16-bit palette color would be 216, 48, and 88, because this meets the criteria above. And again, I always like to tell you what color that looks like, and it's a reddish color. So let's compare some palettes, okay? So let me show you a color, an RGB value that was against a 24-bit palette, where I can pick any value from 0 to 55 that I want. All right, then I go to the 16-bit palette, and I limit myself to those, multiples of 8. And you can see that that color is not far off. And then when I have to go to the 8-bit, so now I'm going to be working with those, 51, 102, those 51 steps. You see the color does get a little different. So there definitely are differences. But, if a lesser bit color palette can achieve your design concept, why not play it safe? All right, so let's go back to RGB. The main problem with RGB is that it's not particularly intuitive. So quick. If I show you the colors on the right, which one do you think is 181, 126, 220? Now, I personally would have no clue. My son just guessed it perfectly, so maybe it's a little more intuitive than I thought. But the reality is that doesn't mean a lot to a lot of people, and you really want a more intuitive approach to defining color. By the way, the answer is it's number 4, which is a lavender color. So fortunately, there is another system for defining RGB colors, and that's called HSL, or hue, saturation, and light. And it says that any RGB color can also be described in terms of hue, which will range from 0 to 360, and we'll talk about that in a second, what that means. Saturation, which relates to the level of grayness in the color, and lightness in terms of how illuminated it is, from 0, which is going to be total darkness, to 100%, which is going to be, fully lit, or white. So let's talk about hue. So what we've done with hue is there are numeric values that are assigned to the different color wheel positions. So let's start with our primaries. So you have red at 0, or you can think of that as also as 360. You got green 120 degrees away, and then you got blue another 120 degrees away. And then in between there, This is where we have our secondary colors, yellow at 60, cyan at 180, magenta at 300. It's kind of a neat acronym or mnemonic device for remembering where those positions are is young guys can be messy rascals. So you start with yellow at 60, add another 60, that takes you to green, another 60 goes to cyan, blue, magenta, red. All right, so if you remember that saying, you will always remember the general number or general value of these colors. From there, I can go ahead and fill in the tertiary colors. Here I'm using some of the other names. So yellow-green, for example, is often sometimes called chartreuse, still the same color. And the other thing you should know is when you look at hues, you're looking at 100% saturation. So it's the pure color, not been graded at all. And it's usually displayed at that middle level between darkness and light, or 50% lightness. All right, so now what we're going to do in activity 1B is we're going to go back and create some colors, but now we're going to do it on an HSL basis. So I'm going to take you to a different tool here. This is with the workwithcolor.com, which has a lot of great tools. What I want you to do is, play with those HSL values to create colors, and see here if you can try to figure out how to make things lighter, darker, or grayer. And I think you'll notice that it's a heck of a lot easier than it is in the RGB system. What I want you to do is go ahead and create a few colors you like, and please note both the RGBV and the HSL values because we will use those later on. All right, and then you're going to come back. So hit the link and see you shortly. Okay, so hopefully you saw that creating colors with HSL is a simpler process and certainly more intuitive. So why not just use HSL all the time, like in our coding? Well, the problem is that not every major browser is going to recognize HSL-based color notation, so that's kind of a bummer. So in the short term, at least for now, the best practice is to go ahead, create your colors using an HSL system, and then use the associated RGB values in your HTML, CSS coding. You should know that there are other color systems out there. HSB, HSV is another one. It works, the hue stands for hue in all three, but the saturation and B stands for brightness, and V, I believe, for value. Those work a little differently, so the numbers will look a little different, so you should be aware of that. But HSL is an easy one to work with. Okay. All right. So before we finish our theoretical portion of this, let's talk a little bit about some key color terms that will be used in the color schemes in our second and third sections. All right. The first one is this concept of complements, and those are colors that are on opposite positions on the wheel. You could also think of that as colors that are 180 degrees apart, because the circle consists of 360 degrees. So as an example, yellow, which is at the 60-degree position, and blue, the 240, are complements. And certainly there are other complements as well. Now, split complement. Now, split complement is color that is, you start with your blue, but this time instead of going directly across to yellow, we go a little to the left, an equal amount to the right, in this case 30 degrees, and we come up with orange and chartreuse as the split complements of blue. Triads. Triads are colors that are three colors that are equally distant on the color wheel. So these colors are going to be 120 degrees apart, and you can also think of this as a special type of split complement where that gap is 60 degrees apart. So for example here, red, green, and blue, all 120 degrees apart, and they form a triad. The reason you can think of it as a split complement is cyan would have been the complement of red at 180, but I go 60 degrees to the left and 60 degrees to the right, and I get my blue and my green. The next one is tetrads, okay? As you might guess, that represents four colors that are equally distant apart on the color wheel. So now it's going to be 90 degrees apart, and four 90-degree angles is going to create a square. And so in this example, my tetrads are red, chartreuse, cyan, and violet. All right, then there's the concept of analogous colors. Now these are colors that are adjacent to each other on the color wheel. So in this example, red, orange, yellow, and chartreuse are all near each other on the color wheel. so they would be considered analogous colors. Then there's the idea of monochromatic, which is you're dealing with one hue, so one position on the color wheel, but then you're working with different saturations and or lightness, so as to create different shades, tints, and tones, but all within the same hue, such as the red monochromatic study you see on the right. Okay, so before we conclude this introductory lecture, 2 activities I want you to take a look at. The first is a game which I think you'll enjoy. It's called Method of Action, and it's a color matching game. And there's going to be 6 different rounds that are going to deal with things like saturation and tetrads and complements. It's a little fun. I think it's addictive. My best score is 8.8, and I encourage you to try to beat that, because I think along the way, as your scores get higher, your understanding of the underlying color concepts will get stronger as well. All right, so then come back to the lecture. And the last thing I want to take you a look at is something that's just a little fun. This idea, since we've been talking about different color spectrums, it's a very interesting lecture by this guy named Neil Harbison, who is actually colorblind, and very interesting how he has gone about creating a color spectrum out of sound. All right, so take a look at that. It's less than 10 minutes, and then we're going to move on to part 2 of the lesson, which is all about application. And then finally in part 3, you'll get a chance to apply some of these color concepts yourself. All right, part 2 and part 3 are going to be self-paced through the PowerPoints rather than a video lecture. So I leave you here, but I hope you enjoy the activities and enjoy the rest of the lesson. Thanks for your time.